Hi YouTube, now I am going to show you how to find input impedance when load impedance and length of transmission line is provided. So we have a Smith chart and we have to plot it in the black magic design of Smith chart. So first we have given input load impedance ZL 25 plus J50. Then the transmission line length we have provided, that is 3.3 lambda, and from that we have to calculate Z in. So we know that this is transmission line, this is ZL, this is transmission line length L, which is given as 3.3 lambda, and we have to find Z in. So we have to move from ZL to Z in, so we have to move towards generator. So remember it, then we are using it afterwards. Okay, so first normalize the load impedance, normalize ZL. So we have provided, we know that the normal characteristic impedance is 50 ohm, so divide it by ZL by Z0, 25 plus J50 divided by 50, so we get 0.5 plus J1. So this is our normalized Z impedance. So this impedance we have to plot here. We know that these circles, that we know that these circles are resistance circles, these circles are inductive circles, and this is capacitive reactance. So we have normalized impedance, that is on the resistance circle, is 0.5, so move from 0.5, and J1, extend it, we get 1 point. So we can write it as ZL, which is normalized value. So we have plot normalized value in Smith chart. Then you have to here extend it from ruler. This ZL, from this we get the angle, because we have to find reflection coefficient. Which is in the angle and magnitude form. So angle we can calculate from this chart. So we can see here, this is 80, 81, 82 or something. I have misplaced here something. It is around 83 degree. So we got this 83 degree, around 83 degree. So make it round figure. Okay. So we get the reflection angle here 83 degree, but how to calculate magnitude value? So we can calculate from here. We can see that this is out, some measurements are given, so we can calculate it. So we can calculate reflection coefficient from this first calculate this, first measure this side, then draw the circle around the ZL. After that, take a 5 centimeter. Take the center and measure it as. So we can see here, if you zoom, we can read this value 0.6, 0.62, 0.64 or 66, in between 64 and 65, 66. So we can write here that reflection coefficient is 0.65 or 645, is I am putting here approximation. So we can calculate it here, reflection coefficient. Now we have to find input impedance, and we have provided transmission line length, which is 3.3 lambda. We know that whole circle, when we move around whole circle, it is 360 degree, and in Smith chart it is written as lambda by 2, means 0.5 lambda. So 3.3 lambda we have to uh, 3.3 lambda means 0.5, turn around, take a round for 6 times, so we get 3, so 3 lambda. Then again means we have to start from ZL, 1, 2, 3, 4, 5 and 6. After 6 we have to move 0.3 lambda from ZL, and after that moment we get Z in value, normalized Z in value, and after multiplication with 50 ohm it get actual Z in value. So first we have to move from ZL to Z in for 3 lambda. We know that 180 degree represent 0.5 lambda. So sorry, 2.5 lambda. So sorry, 0.25 lambda. Okay. 0.25 lambda. So if we move from ZL to Z in for 180 degree, we get we are moving from now for 0.5 lambda. So zoom it out, zoom in here. We can see here. I forgot to tell you what actually done why we are using if you see here, wavelength toward generator, why we are moving from this to this side, because if we see this diagram, we have provided ZL and we have to find ZD. So we are moving from load to generator. So because of why we are moving from wavelength toward generator, from ZL to Z inside. If we have provided, if in question we have given that, if we are given that ZD is given and we have to find ZL, so move towards load, means we have to move ZD from ZD to ZL. Then you will choose this direction. So why we are moving from ZL to ZL. Now we are on question. Instead of question, now we have moved to 0.25 lambda, and we have to move again 0.5 lambda. Then we get the actual Z in value, normalized Z in value. If you see here, this value is 0.38, 0.382, 0.384, 0.386. So 0.3862, 0.5 lambda. So we get actual value. So 0.386 plus 0.5. We have moved 3.6, 0.5 into 6. Okay. From 0.3 lambda lambda. From 0.3 lambda we have covered 0.25 lambda. So we have to cover only 0.05, not 0.5, then it will make mistake. Then move towards this 0.05, 0.05, not 0.5. So we can see here it is changes from one digit, 0.39, 0.4, 0.38394. So move from 1, 0.1, 0.01, 0.02, 0.03, 0.04, 0.05. So we are moving from this 0.05 to reach this point. We can calculate this point by if we see here ZL and we have extended from ZL to here, then we see these readings 0.13. This is wavelength reading. So from 0.132, if we add this 0.132 in our wavelength, we get 2, 3 and 4. This is our required wavelength. That it moves from ZL to ZD, 0.43. The same point we have it some changes are there that are considerable, but we are not drawing here accurately. Just we have to know the concept only. So draw it. So take a ruler. Just take this point here. I will defeat the point. So I'm saying this is new for me, so it is taking time. You should understand the concept here. Just draw it. Take a point here and draw it here. And you get a point here. You get a point here. I'm zooming in. Okay. May I mark it? I'm using another color. So this is your normalize shading. So make it zoom up here. Okay. So this is your shading, normalize, and you can see here. This is resistance circle. Move to resistance circle. Move towards this resistance circle. You get the value around 0.2 and get value here. If you see, I'm using here. It lies between 0.4 and 0.5, around 0.4. If I have made mistake in some assumption or while drawing, it is approximately 0.4, but it is in downward direction, so Zin can be written